I'm just going to barrel on through this problem. All right, so now let's do information from f prime. So what type of information do we get from f prime in general? I would say there's, I guess, 4 things or 2 things, depending on how you think about it. So Shield says increasing and decreasing, at the intervals of increase, the intervals of decrease, and then local min, local max, local min. Good. So Armand says the slope's increasing or decreasing. Actually, no. So what the first derivative tells you, where the original function f is increasing or decreasing. If you want to know where the slope of a function is increasing or decreasing, where do you get that information? How can you tell if I asked you, where is the slope of f increasing? How would you answer that question? F double prime, that's right, because the slope is really f prime. So if I were to ask you where's f prime increasing, that would, you have to look at the second derivative and look at where that's positive, right? So just make sure we say these things correctly. Oops. Okay, so what is our, let's get that derivative again. It's up here. Okay, so we know that, how do we actually compute all this stuff? Increasing, decreasing, local max, local min. We make a sign chart. Okay. All right, so who wants to tell us what are the cut points for my number line for this? So x equals 1/2 and 2, right? I set this equal to 0, right? I just get 1/2 and 2, and that's it, right? There are no vertical asymptotes to include, and this derivative exists everywhere, so it really is just 1/2 and 2. Okay, so now let's choose some easy test points. So let's choose, say, 0, 1, and 3. Those are probably pretty easy. Okay, so looking at each of these factors, so there's a common factor of 2, that's always positive. The 2x minus 1 gives me negative, positive, positive. And the x minus 2 squared, that's going to give me positive no matter what, right? Because it's squared. So altogether, we get negative, positive, positive. And let's recall, what does that mean about the original function? Negative derivative means the original function is decreasing, and positive derivative means the original function is increasing. So I get here, I'm going to put a down arrow, up arrow, up arrow. Okay, now this is actually kind of interesting. What would this actually look like? Because notice the function is increasing from 1/2 to 2 and from 2 to infinity, but f prime of 2 is equal to 0, right? We know that. So what does this actually look like on the graph? What does it mean? So I have a horizontal tangent line at 2, but the function's actually increasing on both sides. What would that actually look like? Someone have kind of an idea what that might look like? This one. I can't see what the hell you're writing. You want to describe it for us? It's a nice way to describe it, actually. So let's see. So at the point wherever 2 is, let's say I have a horizontal tangent line. Right. And the function is supposed to be increasing both before 2 and after 2. But I do have a horizontal tangent line at 2. So it looks something like this. Right. So we get what's called a saddle point. Okay. So when we get something like this, where we have increasing on both sides, but we did actually have a cut point there, like we actually did have a critical point there, we get something that looks like a saddle. So we don't get a local min, we don't get a local max, we just get this kind of cubic worm looking thing. That's all. All right, so now let's zoom out a little bit so you can see everything. So let's now write down what the answer, all the summary stuff. So where is f decreasing? Where is f increasing? Where does f have a local min? Where does f have a local max? Okay, so what would you write as your answer for decreasing? So this shouldn't be too tough. Good, minus infinity to 1/2. Good, and thank you for including the 1/2. All right, now what about the increasing? Let's see who gets it. Let's see who understands all the little technicalities. I'm predicting a poll question coming, but let's see what people say. Here we go. All right, so I'm just gonna write down the answers I got in chat. Okay, Prar and Colleen have the same answer, so I don't need to copy that. Anton has the same answer. John has the, okay. So it looks like we have 3 unique answers in the chat. So let's see what we got. So just read the choices carefully, right? Where the round parenthesis or the closed bracket is, and the commas. Just read them carefully. Just take your time, and then say where you think. I see some people not even choosing their own answer. All right, one more person. Want to vote? All right, we got 100%. Here we go. All right, let's share the results. Let's see. Oof. All right, so the most common answer was choice A. Choice A is wrong. So the the answer to choice A would be the answer if I asked you the question. Let's zoom in now a little bit. If I asked you the question, where is f prime of x, say, greater than 0? The answer to that question would be 1/2 2 union 2 to infinity, right? But the question is not asking that. The question is asking, where is f increasing? And let's remember what increasing means. Increasing, so I just erased the thing. Actually, let's get it back, actually. Let's see. The graph of this saddle. Yeah, there we go. So remember what increasing means. Increasing means that if you claim that the function is increasing on a certain set, you should be able to choose any two x values in that set, and the larger x value has the larger y value, right? If I want the function to be increasing. All right, so if you claim that this function is increasing in 1/2 to 2, and also 2 to infinity, now that is a correct statement. The function is increasing on each of these intervals. But I want to make sure I have the most exhaustive and inclusive interval as possible. So the actual answer would be 1/2 to infinity, right? I would actually include the 2. Right, why am I including the 2? Well, go back to the definition of increasing. If I choose two x values in this set, let's make one of them 2. So I choose 2 as one of my values. I choose just some other x value. Does the larger x value always have the larger y value? Seems so, right? Just because there's a horizontal tangent line there, that doesn't mean the function's not increasing on an interval containing that point, right? I think some students, actually even in higher math, they get confused about this. It makes no sense to talk about a function increasing at a point. So if your objection is, oh, the function is not increasing at x equals 2, that doesn't make sense because functions are not increasing at a point. Functions are increasing on an interval or some, or a union of intervals or a separated list of intervals. So don't think that just because there's a horizontal tangent line there, that the function is not increasing the whole way through. It is increasing the whole way through, right? Do the values ever go down? No. So therefore it's increasing. Okay. But that is tricky. All right, where do we have a local minimum, if any? X equals 1/2, right? And what about a local maximum? None. Okay, good. So that's it for the